Good day, everyone. We will discuss optimization using calculus. This topic represents one of the most important applications of calculus. So what is the importance of optimization in every decision process? Or how will you maximize or minimize something when you go to school, when you go to shopping, or when you go to church? Or a specific example, what route will you take to minimize time travel or to minimize traffic congestion? Or what to wear? How will you maximize your appearance or your personality based on your clothes? Or what food to eat to minimize cost or to maximize your hunger satisfaction? Or when you sleep or when you rest? At your age, you should maximize the 8-hour sleep, right? Or when you study, your study hours, it's either failure in course versus lacking time to do other aspects of life. Example, time for family, time for your social life, right? So it's like how will you maximize or minimize every decision that you will make. So for this discussion, I want you to have the idea that logical decisions in real life are made by optimizing some quantities or your objectives that depend on things you can control, or we can model that, or we can let that as our variables. Of course, in real life, there are several objectives and variables involved. So in this, we will only be concerned with problems with one objective that depends on controlling only one variable. So we will recall the key concepts in the topics from your general mathematics subject, those functions that used to describe physical phenomena, for example, the number of people, and letting that to any variable in a certain area that is infected by an epidemic after some time t, or the concentration C of a drug in a person's bloodstream T hours after it was taken, or the mice population Y as the snake population X changes, etc. So those are just um, topics that we need to recall in discussing this um, optimization using calculus. Let us first go with the definition. Let f be a function that is continuous on an open interval I containing x sub 0. So we say that x sub 0 is a critical point of the function f if the derivative at x sub 0 is equal to 0, or the derivative at x sub 0 does not exist, that is, f has a corner or a cusp at x sub 0 f of x sub 0. Or in short, the function or the derivative of the function does not exist on a certain number or certain value of x. Or another way of saying is that the function is not differentiable at x sub 0. And we say that the maximum of f occurs at x sub 0 if the value f of x sub 0 is the largest among all other functional values on I, that is, f of x sub 0 is greater than or equal to f of x for all x in I. And we say that the minimum of f occurs at x sub 0 if the value f of x sub 0 is the smallest among all other functional values on the interval I, that is, f of x sub 0 is less than or equal to f of x for all x in that interval. We say that an extremum of f occurs at x sub 0 if either we have a maximum or a minimum value that occurs at x sub 0. So for example, we have a function 3x squared minus 3x plus 4. And we are asked to find all critical points of the given function. So first, again, we will get the derivative of the function. So the notation for derivative, we have f prime of x is equal to, using the rules of differentiation, we will get the derivative of 3x squared, derivative of negative 3x, and the derivative of 4, or the derivative of a constant. So what is the derivative of 3x squared? That is 3 times 2, that is 6x, 2 squared here, minus 1, so we have 1 here. Or understood that it has a power of 1. Minus derivative of 3x, that is 3, right? Because we have x here with an exponent 1 minus 1, and that is equal to 0, and x to the power of 0 is just equal to 1 times 3, so we have 3 here. Plus the derivative of a constant, and that is 0. So we have the derivative of the function, that is 6x minus 3. Next step, to get the critical point, we will equate the derivative of the function to 0. So from here, we have 6x minus 3, equate that to 0, and we solve for x. So what is x? What is the value of x here? So we have 6x equal to, we have transpose 3, and we divide both sides of the equation by 6. So divide 6, divide 6. So we have x is equal to 3 over 6, or that is 1 over 2. So we have a critical point, x equal to 1/2. And the other way of finding a critical point is that if the derivative of the function does not exist. But since the function is a polynomial, then it is continuous everywhere. So as the derivative of the function, still a polynomial, this will exist at any values of x. This will exist at any value of x. So we only have x equal to 1/2 as our critical point. Another example, we have the function x cubed minus 9x squared plus 15x minus 20. So again, first step is to get the derivative of the function. So what is the derivative of the function? We have x cubed here, so we have 3x squared using the power rule, right? Power rule, if we have a function x to the power of n, then the derivative is x n minus 1. So we copy the exponent 3, copy x, then 3 minus 1, that will give us 2. Minus 9x squared, using the multiple constant rule, if we have cx to the power of n, then the derivative will give us c times n, x, n minus 1. So we have 9 times 2, that is 18x, 2 minus 1, that will give us 1, right? So we have negative 9x squared. The derivative of that expression is negative 18x plus 15x. We all know that this has an exponent 1. So 1 minus 1, 0. Then x to the power of 0 is 1 times 15. So we have 15. Then the derivative of a constant equal to 0. So we have the derivative of the function. Next is we will equate the first derivative to 0. So second step. So we have 3x squared minus 18x plus 15 equal to 0. So from here, we can do factoring, and we have here a common monomial factor of 3. So out is 3. So 3 is out. Then we only and we are left with x squared. Negative 18 divided by 3, that is negative 6x. 15 divided by 3, that is 5, equal to 0. So we have an easier polynomial to factor. So we have 3 times x and x here equal to 0. So what are the factors of 5 that if we sum this up, this will give us negative 6. So we have negative 5, negative 1. Negative 5 times negative 1, that will give us positive 5. And negative 5 plus negative 1, that will give us negative 6. So we have the factors of 3x squared minus 18x plus 15 equal to 0. So from here, we have x minus 5 equal to 0 and x minus 1 equal to 0. That is x equal to 5 and x equal to 1. So with 3 is equal to 0 and that cannot be. So we only have x equal to 5, and x equal to 1 as our critical points for the given function. So another example, we have x cubed minus x squared minus x minus 10. So again, the first step is to get the derivative of the function. So we have 3x squared minus 2x minus 1. Second step is to equate 3x squared minus 2x minus 1 to 0. So we have to factor this out. We have 3x here and x equal to 0. So we have plus 1 and minus 1 since 1, positive 1 times negative 1 is negative 1, right? We got this one. And if we multiply the inner part and the outer part, so we have negative 3x plus x, right? So we have negative 3 plus 1, we have negative 2x. So we got the middle part. So we have the following factors. Next is 3x plus 1 equate to 0 and x minus 1 equate to 0. So we have 3x equal to negative 1 and x is equal to negative 1/3 and x equal to 1. So we have the following critical points. So again, this is polynomial function. So it will exist at any value of x. Another function, we have x minus 3x to the power of 1/3. First step is to get the derivative of the function. Derivative of x is 1. Derivative of negative 3x to the power of 1/3 is negative, copy 3 times 1 over 3, the exponent, copy x, and then 1/3 minus 1. So that will give us 1 minus 3 times 1/3 is just 1, right? So we have x, 1 times x, x, to the power of 1/3 minus 1, that will give us negative 2 over 3, right? So from this, from the derivative of the function, we can also write this as 1 minus, since we have a negative exponent here, to make it positive, we will write this as 1 over x to the power of 2/3 to get a positive exponent. Or, we can always simplify this one, since the denominator or the LCD is x to the power of 2/3. LCD divided by the denominator 1, right? This is just over 1. So we have x to the power of 2/3 times 1. So we have x to the power of 2/3. Next, LCD divided by the denominator x to the power of 2/3, that is 1, times negative 1 will give us negative 1. So we can have this one, or this one, or this one. So next step from here, this is um, the easiest expression to use when we will equate this to 0. So x to the power of 2/3 minus 1 divided by x to the power of 2/3, equate that to 0. So to get rid of this, we will multiply both sides of the equation by x to the power of 2/3. So we are left with x to the power of 2/3 minus 1 equal to 0. Since 0 times x to the power of 2/3 is still 0. So we have x to the power of 2/3 equal to 1, right? So what is the value of x? So if we have x squared equal to 1, we will get the square root for both sides of the equation, right? So we have a positive negative here. So we get x equal to positive negative square root of 1, that is 1. So we are given two values of x. So if we have x to the power of 2/3 equal to 1, or another way of writing this from x squared equal to 1, we will raise this to an exponent 1/2, also the other side of the equation. To get 2 times 1/2 will give us x equal to 1 to the power of 1/2 can be written as the positive negative square root of 1, right? So we will recall the lessons having exponents, or the law of exponents. So from here, we also have x to the power of 2/3 raised to the power of 3/2, the reciprocal, equal to 1 raised to the power of 3/2. Since we also have over 2 here, so that means we will get the square root of 1 cube, right? So still positive negative. So that will give us x equal to positive negative. We have 1 cube is 1, square root of 1, 1. So still, we have two values of x here. We have positive 1 and negative 1. So we have critical points, x equal to 1, x equal to negative 1. And if we have determined the domain of the function is the set of all real numbers. So we can take negative 1 as our critical point, since still it belongs to the domain of the function. Another way, the third step is to determine the values of x that can make the denominator of the derivative 0. So what values of x? Here. This is the derivative of the function. And on what values of x will the denominator become 0? That is, if x is 0, right? So we will also consider x equal to 0 as our critical point. So we have 3 critical points for this function. Two critical points from the derivative equate to 0, and 1 critical point where the derivative of the function does not exist when x is equal to 0. Another example. So we have x to the power of 5 over 4 plus 10 x to the power of 1 over 4. So what is the derivative of the function? So using the power rule, we have 5 over 4 x 5 over 4 minus 1 plus 10, copy 10, using the multiple constant rule, times 1/4, copy x, then 1/4 minus 1. So to simplify this one, we have 5 over 4 x 5 over 4 minus 1 is 1 over 4 plus 10 times 1/4, that is 10 over 4 x 1/4 minus 1, that will give us negative 3 over 4. Or we can write this as 5 over 4 x 1/4 plus 10 over 4. We will put this below. So this becomes our denominator, x to the power of 3 over 4, to make it a positive exponent. So from this, we can rewrite this as the LCD as 4x to the power of 3 over 4. So LCD divided by 4, we have x to the power of 3 over 4 na lang, times 5x to the power of 1/4. That will give us 5x 3 over 4 times x to the power of 1/4 plus LCD divided by the denominator. We have 1 times 10, so we have plus 10. So what is the product of these variables? So we have copy 5. So same base. So 3/4 plus 1/4. That is 4 over 4, or that is 1. So we have 5x here plus 10 divided by 4x to the power of 3 over 4. Right? So we can have this one, or you can factor the numerator, and that becomes common monomial 5x plus 10 divided by 5. So we have 2 over 4x power of 3 over 4. Or these are just equivalent expressions. So from here, We will equate this to 0. So we have 5 times x plus 2 divided by 4x to the power of 3 over 4. By the way, you can equate this to 0, this expression, or you can equate this to 0, or you can equate this to 0, or this expression equate to 0. This will give you the same result, actually. So equate that to 0. You multiply both sides of the equation by 4x to the power of 3 over 4. So you multiply this one, distribute that one. We will have 5 times x plus 2 equal to 0 times this expression will give us 0. So we divide both sides by 5. So we have x plus 2 equal to 0 left. And then x is equal to negative 2. So the question is x equal to negative 2 can be a critical point for the given function? Is it a critical point? The answer is no, because the domain of our function, again, we recall how to determine the domain of the function. So the domain of the function will only comprise from 0 to positive infinity. Why is that so? Because if we have a negative value here, actually you can verify this with your calculators. So if we substitute a negative number, for example, you can have negative 1. So x to the power of 5 over 4, kanipalandaan, if x is equal to negative 1, this can be written as x to the power of 5. So we will get the fourth root of x to the power of 5. So if we have a negative number here, if x is equal to negative 1, substitute this to the expression, then fourth root of negative 1 to the power of 5, negative 1 to the power of 5 is negative 1, right? And if we have an even index here, even po, so we have square root, fourth root, the sixth root, so we have even index. Ito po. The domain of this expression or the function should be x greater than or equal to 0. This cannot be a negative number. So from this, the domain of our function is from 0 to positive infinity, including 0. So all negatives, all negative number, hindi po siya kasali sa domain ng ating function. So, x equal to negative 2 as our critical point cannot be. So, we cannot so negative 2 cannot be a critical point. So, another way, since we don't have a critical point when we equate the derivative of the function to 0, then another way of finding a critical point is to determine a value of x that can make our first derivative undefined. So that is when the denominator is 0, right? So if we have x here equal to 0, then 4 times 0 to the power of 3 over 4 is still 0. So we only have x equal to 0 as our critical point. So now, we will discuss the theory behind optimization using calculus. The first theorem is Fermat's theorem. Let f be continuous on an open interval I containing x sub 0. If f has an extremum at x sub 0, then x sub 0 must be a critical point of f. So again, if the function has an extremum at x sub 0, so that is either a maximum value or a minimum value, then x sub 0 must be a critical point of f. So to illustrate this, for example, let's consider the graph here. So at this point, we have a maximum, right? And at this point, we have a minimum. So since the function is continuous on an open interval, then if this is a maximum, then x sub 0 here is a critical point. Also, if this is a minimum, then x sub 0 here is also a critical point. So that is Fermat's theorem. Another theorem is the extreme value theorem. Let f be a function which is continuous on a closed and bounded interval AB. Again, f, again, the function is continuous on a closed and bounded interval AB. Then the extreme values, that is the maximum and the minimum values of f, always exist, and they occur at either the endpoints A and B, or at the critical point of f. So it is important to stress the assumptions of the EVT, or the extreme value theorem. The function f must be continuous on an interval that is closed and bounded. So if we have the graph here, we all know that this is a minimum, but we cannot find a maximum here since this is an open interval. This is not bounded. Also, if we have from this point up to this point, but this point does not exist, this is not a minimum, we only have a maximum here, this is bounded, but this is not continuous, and we don't have a minimum value here. So EVT is not satisfied. So EVT should be, or the function should be continuous on a closed and bounded interval. That is the first condition. And a maximum and minimum value always exist, and it will only occur at the endpoints or at the critical points of the function. So for example, find the extrema of the given functions on the interval. When you say extrema, that is the minimum and the maximum values. So we have the interval, closed interval -1 to +1. We have an endpoints -1 and 1. So again, same steps. The derivative of this function is equal to 6x minus 3, right? And to determine a critical point, since this is a polynomial, then it will exist in any values of x. So 6x minus 3, equate that to 0. And we got a critical point 1/2 here on our previous example. This is still the previous example that we used before. So we have -1, 1/2, and 1, the endpoints and the critical point, right? So from this, the endpoint and the critical points will be substituted to the function. Sa function taha. So from this, we will evaluate the functions. We will evaluate the function at -1, at 1/2, and at 1. So we simply substitute the values. 3 times -1 squared minus 3 times -1 plus 4. Using our calculators, we will get 10. So when x is equal to 1/2, 3 times 1/2 squared minus 3 times 1/2 plus 4, that will give us 13/4, or approximately this is 3.25, right? So for f of 1, we have 3 times 1 squared minus 3 times 1 plus 4. And that will give us 4. So when x is equal to -1,
when x is equal to -1, y is equal to 10. When x is equal to 1/2, we have 13/4. And when x is equal to 1, we have +4. So clearly, the maximum value of the function occurs when x is equal to 1, and that is equal to 10. This is the maximum value. And the minimum value of the function f occurs when x is equal to 1/2, and that is equal to 13/4, or 3.25. So we have the maximum value and the minimum value. Another example, find the extrema of the given functions on the interval -1 and 1. So when we recall the critical points of this function, we have x equal to 1 and x equal to 5. We already solved for the critical points of this function a while ago. So we are given x equal to 1 and x equal to 5. And looking at the critical points, we are only limited on our domain, that is from -1 to +1. So we are only interested with x equal to 1. So x equal to 5 here will be rejected since it doesn't belong to the domain or the interval -1 to 1. So, having a table of functional values, we have -1 and +1 only. So, we evaluate the function when x is equal to -1 and when x is equal to 1. So, we have -1 cubed minus 9 times -1 squared plus 15 times -1 minus 20. That will give us -45. So when x is equal to 1, we have 1 cubed minus 9 times 1 squared plus 15 times 1 minus 20. And that is equal to -13. So from this, when x is equal to -1, we have y equal to -45. And when x is equal to 1, we have y equal to -13. So the maximum value is -13, and that occurs at x equal to 1. So this is the maximum value. And the other, -45, is our minimum value, and that occurs at x equal to -1. So for this function, the critical points are x equal to -1/3 and 1. So since this belongs to the interval -1, 1, then we will consider these values having our functional values, our table. We have -1, -1/3, and +1. So again, we will get f of -1, f of -1/3, and f of 1. Using our calculators, this will give us -11, -25/27, or that is approximately negative 0, 0.925 and -11. So we have the maximum value. This is -11, -11, and -25/27. So the maximum value is -25/27, and that occurs at x equal to -1/3, and the minimum value are -11, or is -11, and that occurs at x equal to -1 and x equal to 1. So when we say maximum value, that is the y values, or the function value at x. But when we say maximum point, then that is our x and y. So the maximum point for this function is -1/3, -25/27. And the minimum value is negative 11. So this is negative 25 over 27. And this is negative 11. Then the minimum point will be, since we have two minimum points, that is negative 1, negative 11, and positive 1, negative 11. So another function, we have the critical points of this function are negative 1, positive 1, and 0. And since this belongs to our interval, then we have our table of functional values, negative 1, 0, and 1. Zero and 1. So we evaluate the function at negative 1, at 0, and at 1. So we have negative 1 minus 3 times negative 1 to the power of 1/3. This is equal to 2. And when x is equal to 0, we have 0 minus 3 times 0 to the power of 1/3, and that will give us 0. And when x is equal to 1, 1 minus 3 times 1 to the power of 1/3 equal to negative 2. So we have 2, 0, and negative 2. So from here, the minimum value is negative 2, and the maximum value is positive 2. The minimum point is 1, negative 2, and the maximum point is negative 1, positive 2. So what if we are given a function of this type? We have 2 sine x minus x. So same steps. We are to find the derivative of the function. So the derivative of sine x is cosine x. So we have 2 cosine x minus the derivative of x is 1. And then we equate the function or the derivative of the function to 0 to get the critical points. So if we are bounded with the interval from 0 to pi over 2, so we will only consider critical points inside this interval. So from this, we have 2 cosine x equal to 1. And cosine x, we divide both sides by 2. So cosine x is equal to 1 over 2. So to get the value of x, we have the cosine inverse 1/2. And using our calculators, that will give us 60 degrees, or that is pi over 3. Right? So we will recall the lessons from our trigonometry. So another way of saying this is when does our x value or when or on what angle measure does our cosine x equal to 1/2. So from 0 to pi over 2, we only have pi over 3. Or the or if we will solve this one, cosine 60 degrees, that will give us 1/2. So we are right that cosine x equal to 1/2. That is when when our angle measures 60 degrees, or in radian measure, that is pi over 3. So we have the critical point, pi over 3. So using the table, we have 0, we have pi over 3, and pi over 2. Right? So if you will recall this one, this is 0, this is pi over 4, this is pi over 6, this is pi over 3, and this is pi over 2. So this belongs, pi over 3 belongs to the interval from 0 to pi over 2. So again, cosine inverse, you can get that when in your calculator you can have shift plus cosine. So we have cosine inverse. So we will have f of x equal to, or so we will have f of 0 equal to 2 sine 0 minus 0. So that will give us, using our calculators, that is 0. So when x is pi over 3, we have 2 sine pi over 3 minus pi over 3. So that will give us, be sure, when we use the radian measure, your calculators should be on radian mode. So that will give us approximately 0.68. And when we have f of pi over 2 equal to 2 sine pi over 2 minus pi over 2, that is equal to approximately 0.43. So from this, approximately 0.68 and approximately 0.43. So the maximum value is 0.68 and the minimum value is 0. So we're done with how to get the critical points, the maximum value and the minimum value of functions. So many real-life situations require us to find a value that best suits our needs. If we are given several options for the value of a variable x, how do we choose the best value? Such a problem is classified as an optimization problem. So we will apply our previous discussion in finding the extremum values of a function to solve optimization problems. So here are the suggested steps in solving optimization problems. If possible, draw a diagram of the problem. Step 2, assign variables to all unknown quantities involved. Number 3, we specify the objective function. So this function must be continuous. So in this, we identify the quantity, say q, to be maximized or minimized. We also formulate an equation involving q and other quantities. Express q in terms of a single variable, say x. If necessary, use the information given and relationships between quantities to eliminate some variables. So the objective function is maximize q equal to f of x or minimize q equal to f of x. Fourth step is to determine the domain. It is very important that we determine the domain or constraints of q from the physical restrictions of the problem. The domain must be a closed and bounded interval. So we recall EVT here, the extreme value theorem. And fifth step, use appropriate theorems involving extrema to solve the problem. Make sure to give the exact answer with appropriate units to the question. So for example, find the number in the interval -2 to +2 so that the difference of the number from its square is maximized. So, first step, since it is not possible to draw a diagram, so we will not draw a diagram. Step 2, we assign variables to all unknown quantities involved. So, since we are asked to find a number, so we let x be the number. We can say that one. We can have that one. So x here is any number that is in the interval -2 to +2. And then we specify the objective function. So our function here is to be maximized. We have this. So if we are to find a function, or we have to formulate an equation involving our variable x, then we will make use of the phrase, the difference of the number from its square. So what do you mean by that? So we will have a function that is, or that will satisfy the given phrase. Since x is the number that we are looking for, and it says that the difference of the number from its square, so meaning we have a number squared, and we have 2 minus a number, or the number. So we have the difference of the number from its square. So we have the function x squared minus x. And since our function is continuous because it is a polynomial function, so it is continuous in the interval -2, 2, since it is also continuous in the domain, which is the set of all real numbers. But we are only tasked to find a number x in the interval -2 to +2. So we can apply EVT here, or extreme value theorem. So again, our first step is to find the derivative of the function. So what is the derivative of x squared minus x? That is 2x minus 1. And third step, or the next step, is to equate our function to 0, or the derivative of the function to 0. So 2x minus 1, equate that to 0. And what is the value of x? X is equal to 1/2. And 1/2 is in the interval -2 to +2. So we have a critical number here, or critical point. So from this, using EVT, we have our table of function values. We have -2, 1/2, and +2. So we will complete this. When x is equal to -2, f of -2 is equal to, we will substitute it here. So -2 squared minus -2, that will give us 4 plus 2 equal to 6. How about f of 1/2? F of 1/2, that is 1/2 squared minus 1/2. And that will give us 1/4 minus 1/2, that will give us -1/4, right? How about f of 2? F of 2 is equal to 2 squared minus 2. So that is 4 minus 2 equal to 2. So from this, we conclude that the function attains a maximum at the left end point, which is at x equal to -2. And the value is 6, right? So the number we are looking for, the number x, this is x, and these are y's. So 1/2, this is so -1/4, 2, we have 2. So from this, maximum value is 6, and it occurs at x equal to negative 2. So x here that we are looking for is negative 2. Did you get it? Another example. A rectangular box is to be made from a piece of cardboard. A rectangular box is to be made from a piece of cardboard 24 centimeters long and 9 centimeters wide by cutting out identical squares from the four corners and turning up the sides. Find the volume of the largest rectangular box that can be formed. So, if we draw the problem or the figure, we are given a rectangular piece of cardboard that is 24 centimeter long. This, from this to this is 24 centimeters and 9 centimeter wide. Right? Next is, so from this piece of cardboard, we are asked to make a rectangular box. So if we have a box, then it has a height. So to make it a box, we will cut out identical squares. So identical squares from the four corners. So we have 1, 2, 3, 4. And since it is a square, then we can name this as x and x. So it has the same length since it is a square. Also with this, since they are identical squares that to be cut out from the four corners. So what will happen if we will cut this out and then fold it up, this part, so we can make a rectangular box, right? So we will define this variable. So we let x be the length of the side of the squares. To be cut out. So we can have that one. So what will happen if we will cut out these squares from this side? So we will have 9 minus what is the length of this part. Since this is x, this is also x. And since this is x, this is also x. So how many x we will cut out? So minus 2x, right? So from here, another 2x. So we have 24 minus 2x, right? So the length and the width are given below. So the length of the box is 24 minus 2x, and the width is 9 minus 2x. So the height, since it is a box, so the height will be the length of the square, that is x. So since we are to find the volume of the largest rectangular box that can be formed, we can denote the function as v of x. Since the volume of the box is length times width times height, so we have 24 minus 2x times 9 minus 2x times x. That is the length, the width, and the height, right? So you multiply that one, that will give us this will give us 24 times 9 times x, or so this will give us, if we multiply this 3, so we have 216x minus 66x squared plus 4x cubed. So we have our function here, 216x minus 66x squared plus 4x cubed from this here. So since we wish to maximize the volume, but we should note that x here should be non-negative. So this cannot be 0, this cannot be negative number, and should not be more than half the width of the cardboard. Right? Did you get that? X should not be more than half the width of the cardboard. Since, from this, we have the width of the cardboard, that is 9 centimeters. And if we cut out x here, or rather 2x, so it should not be more than 9 centimeters, right? Since if this will be more than half of the width, so let's say the half of the width is 4.5, so if we cut out a 5 centimeter, let's say that will be the x, then 2 times 5, 10. 9 minus 10, then we will have a negative width here, which is cannot be. So x should be, or should be in the interval from 0 to 4.5 only, because we are safe with that. 2 times 4.5 is just 9. So 9 minus 9, 0. And we will not have a card. We will not be able to make a rectangular box out of the cardboard. So the end point should be the half of the width of the cardboard. So we have the interval here from 0 to 4.5. So we will find a value of x that is in the interval 0 to 4.5. So we have a closed and bounded interval. So we can make use of EVT here, right? So from this function, we will make use of the formulated function here, or equation. So we have it here. Next step is to get the derivative of the function, and that is 216. The derivative of 216x is 216 minus 66 times 2, that is 132x minus 1 here, so we have an exponent 1, plus 4 times 3 is 12x minus 1, so we have squared. Okay, so next step, we may rewrite this as 12x squared minus 132x plus 216. We equate that to 0. And since from the three terms, we have a common monomial factor of 4. So 12 divided by 4, we have 3x squared minus 132 divided by 4, that is 33x, plus 216 divided by 4, that is 54, equal to 0. So we further factor this. We have 4 times, we have 3x and x equal to 0. So we have factors of 54. We can have negative 9 and negative 6. So 6 times 9, that is 54. And if we multiply the inner part, that is negative 6x, and the outer part, that is negative 27x. So we get the sum. So negative 27 minus 6, that will give us negative 33x. So we have the factors. So from this, we have 4 equal to 0, which is cannot be. We have 3x minus 6 equal to 0. So x is equal to 6 over 3. And that will give us x equal to 2. And then x minus 9 x minus 9 equal to 0. So that is x equal to 9. And so we got x equal to 2 and x equal to 9. But since x should be in the interval from 0 to 4.5, then x equal to 9 is rejected, since this is outside the interval. So we only have x equal to 2 as our critical point or critical number. So we now compare the functional values at the endpoints 0, the critical point 2, and another endpoint 4.5. So we have the x and the y, or this is our v of x. So we substitute the value of x to our function here. Not on the derivative, huh? We are to evaluate the function since our function is yet to be maximized. Is about to maximize, or since our function should be maximized. Not on the derivative, but on the function itself. So, 216 times 0 minus 66 times 0 squared plus 4 times 0 cubed, we have 0. And if we substitute 2 here, we get 200. And also, if we substitute 4.5 here, and if we substitute 4.5 as our value of x, we got 0. So from the table, we see that the volume attains its maximum value, which is 200, at x equal to 2. So the value of x is equal to 2 according to the table, and the maximum value or the maximum volume is equal to, that is V of 2 equal to 200 cubic centimeter. So this is the volume of the box, and that is attained when x is equal to 2. And we're done. So if you have questions, you may raise it in our GC or Messenger, Google Classroom. Make a message there or comment to help you with the problem that you are encountering. So have a good day, everyone.